Yesterday, we talked about the different types of systems with inconsistent and then consistent, independent, consistent, dependent. Yesterday was also dealing with graphing. Today, we're going to look at the identifying the system type without graphing. So let's take a look at our first example, letter A. We have y equals 7x plus 8 and 3x minus 9y equals 14. Our first step is going to be to put those equations into y equals mx plus b form. And so when we do that, I see that my first equation here is already in y equals mx plus b form, or slope-intercept. So I need to take my second equation. We've got 3x minus 9y equals 14, and I want to put this into my slope-intercept form. So first, I'm going to subtract 3x. Once again, I can't reinforce enough that this is a positive 3x, so we need to subtract it to get rid of it, which then gives me negative 9y equals negative 3x plus 14. And then I'm going to divide everything by negative 9, which will give me y equals 1/3, once I simplify, x minus 14/9, which I'm just going to leave it since I don't have to graph it. Step 2 is going to be to look at the slopes. If the slopes are different, then we have one solution. Well, I see here that I have a slope in my second equation of 1/3 and a slope in my first equation of 7. They are different. That means they have one solution, which in our case is going to be independent and consistent. Now to move on, just so we can have our information for the rest of it, if they are the same, then you need to look at the y-intercept. If they have the same slope and the same y-intercept, then it's an infinite number of solutions, which would be our consistent and dependent. And if they have different y-intercepts and they have the same slope, then this is going to be inconsistent. So knowing that, let's take a look at our next example. We have here 6x minus 3y equals 8 and y minus 4 equals 2 times x minus 1. We have the same situation where we have to get them both into y-intercept form, or slope-intercept form. So we're going to take our 6x minus 3y equal to 8, and we will subtract 6x from both sides, giving us negative 3y equals negative 6x plus 8. Divide both sides by 3, negative 3. Divide all things by negative 3, giving me y is equal to negative 6 divided by negative 3 is positive 2x minus 8/3. So then I can go and take a look at the second equation. We have y minus 4 equals 2 times x minus 1. I'm going to go ahead and distribute, giving me y minus 4 equals 2x minus 2. Remember, you have to distribute to both terms in parentheses. And then finally, we're going to add 4 to both sides, which is going to give me y equals 2x plus 2. So I see, looking back up here at my rules, if they're different slopes, they have one solution. In our case, I see that I've got a slope of 2 and a slope of 2. So our slopes are the same, so we look at the y-intercept. We have here a y-intercept of negative 8/3 and a y-intercept of positive 2. That means that these are inconsistent because they have the same slope, but they have different y-intercepts, which means that they are going to be parallel to each other. Let's look at another example here. We have 4x plus y equals 5, and y plus 3 equals 4 times x plus 2. So if we take a look at our first equation here, 4x plus y equals 5. I'm going to subtract 4x from both sides, which is going to give me y equals negative 4x plus 5. Then we look at our other equation, y plus 3 equals 4 times x plus 2. We can go ahead and y plus 3 distribute here, giving me 4x plus 8. Subtract 3 from both sides, which gives me y equals 4x plus 5. Now, I look here, they look pretty close to the same, but this one is a positive 4 and this one is a negative 4, which means that they do not have the same slope, which means that these are going to be consistent and independent because they have exactly one point of intersection since their slopes are different. What you need to do now is to go ahead, try the you try it problems, identify the systems without graphing, write your summary, bring your questions to class tomorrow.